This star, called Methuselah, is older than our universe itself. All the initial calculations provided by scientists show the same numbers. This distant object is 14.5 billion years old. This is 700 million years older than the universe. But that can't be true. Astronomers spent 8 years searching for an error in the calculations and finally managed to squeeze the incredible star into the timeline of our universe. Now Methuselah is officially 12 billion years old. At the same time, our world is full of mysteries that have never been solved. Some star systems are so strange that their unique features keep many astronomers awake at night. This planet is about the size of Earth, but it's 100 times closer to its star. Due to this abnormal proximity, the surface of Kepler 7a b is heated to 2,500 degrees Celsius. And according to all our current knowledge of space, such an extreme world is not supposed to exist at all, since planets never appear that close to their stars. It's like finding a pizza in a crater of a volcano. To date, there's not a single scientific model that can explain what kind of forces could place Kepler 7a b in that monstrous forge. We should unravel this phenomenon as soon as possible, since in just 3 billion years, the planet will fall on its star and take its secret to the grave. But maybe, at least by that time, astrophysicists will have determined why none of the known stars flickers the way Tabby's star does. When an exoplanet moves in front of a regular star, the star's brightness decreases by no more than 1%. However, something weird is going on around Tabby's star. Its brightness repeatedly drops by a totally unthinkable 22%. Scientists are confused. Planets, dust clouds, or asteroid clusters cannot obscure the star that much. I have the impression that someone's using Tabby's star as a background for a space shadow play. A somewhat less fantastic theory states that a Dyson sphere encompasses Tabby's star, and aliens there built it to capture the star's energy. But scientists, as we know, generally reject resorting to the possibility of alien life and aren't going to cave, so the mystery around Tabby's star remains unsolved. And while anomalies related to star systems only perplex researchers, the strange behavior of some larger objects actually frightens them. These galaxies have defied all the laws of physics. This ancient quasar with an unpronounceable name is a galactic nucleus powered by a supermassive black hole. This monster is even older than the Methuselah star, as it formed just 900 million years after the Big Bang. This is an extremely early time if we look at the entire history of the universe, but even this period was somehow enough for this black hole to become as heavy as 12 billion suns. Imagine something like a 2-year-old child with a wrestler's body weighing 100 kilograms. So creepy. And that's not all. This quasar's energy repels all matter, so it's absolutely and entirely unclear what this black hole actually feeds on, as if the quasar has a granny that spared no effort in fattening it up while its parents were away. But sometimes the mystery lies in a space giant's brightness and not in its mass. HD 1 is the oldest and the farthest galaxy from us. It's 13.5 billion years old, and it's still inexplicably bright. Astronomers managed to take this photo only with the help of powerful ultraviolet radiation. This means massive blue stars appeared in HD 1 long ago, at the dawn of time. The confusing part is that their light is at least 10 times brighter than it was thought possible. It's the same as if you installed bright headlight bulbs on your car and then, after turning them on, realize that the distant light burns through trees. According to one version of events, the abnormal glow of the galaxy is generated by its quasar and supermassive black hole. But this gives rise to a new contradiction about robust black holes that gain too much mass in their early years. Same old story. Anyway, whatever the reason behind HD1's mysterious glow is, it will probably soon be found by the James Webb Space Telescope. Astronomers earnestly hope that the James Webb will also manage to shed light on other phenomena of genuinely universal proportions. The outer space we explore often goes against the laws of physics and common sense. This is not a simple constellation. That's an extensive construction composed of many galaxies and called the Hercules Corona Borealis Great Wall. It occupies as much as 10% of the observable universe. All experts stick to the cosmological principle, which says that a structure of that sort simply cannot exist. That's because space should be homogeneous, just like the white noise you can see on an old-school TV screen. The biggest object you can see there is a pixel. If we're talking about outer space, this would be a galaxy cluster spanning no more than 300 million light-years. But the Hercules Corona Borealis Great Wall is more like a line going across the screen. Its size exceeds the maximum limit almost 33 times. So it's either a figment of scientists' imagination or a project completed by an ancient alien construction company. I bet if we could somehow talk to those guys, they could answer all our questions about the abnormal size of the universe. Sound logic says that if there's nothing faster than the speed of light in outer space, and it's been almost 14 billion years since the Big Bang, then the diameter of the observable universe should be only 2 times greater, around 28 billion light-years. However, astronomical data prove that the universe swelled 3 times as much and reached 93 billion light-years. How is that even possible? It's like buying a balloon and suddenly finding out that you can inflate it to the size of an airship. Scholars explain this unbelievable expansion of the universe with the help of, can you guess, inflation theory. Inflation theory states that after the Big Bang, our universe grew from a subatomic particle to an infinite thing in less than a split second. Researchers had no other choice but to consider the possibility that space can expand faster than the speed of light. But even that doesn't clarify all the weird discoveries that were previously made, so astronomers keep arguing over the exact rate of cosmic inflation. The main reasons behind the discrepancies lie in the very fabric of the universe. The most inexplicable phenomena in the universe are closely connected to the behavior of matter. The bullet cluster looks like it's almost literally haunted, and these ghosts couldn't care less if you don't believe in them. In this area, 2 separate galaxy clusters collided at 4.5 thousand kilometers per second. The impact was so violent that at full speed, they beat massive clouds out of each other. This looks very similar to the way a soul leaves a body in animated movies. But then it turned out that both clusters still had some kind of another invisible soul containing most of their masses. Could these galaxies have 9 lives like cats? There's only one possible explanation for what's going on in the bullet cluster: dark matter, even though it's even more elusive than ghosts, as scientists are still struggling to find its particles or to understand their nature from the perspective of modern physics. But here's an even more puzzling question. Why do galaxy clusters exist in the first place? Paul Dirac, a physicist, estimated that the energy of the Big Bang should have created 2 types of matter in equal proportions. These are matter and antimatter. At some point in our universe's life, they were supposed to meet and become pure energy, like in the good old days. But instead, we have a lot of stars and galaxies consisting of regular matter, and it seems that there's no antimatter at all. At the moment, our world looks as unnatural as an ancient civilization without a single man. Sorry, dear Amazons, we're talking science here. Researchers assume that antimatter turned out to lack 1/billionth of regular matter's stability, but nobody knows why. An alternative theory suggests that antimatter didn't vanish anywhere because the Big Bang gave birth to a pair of universes instead of only one. This means that there's another world with a counter-Earth inhabited by our counter-selves. Well, that's a perfect deduction. Its only flaw is that it's unprovable. And even if we did find a way to connect to the anti-universe, we'd destroy both of the worlds by transforming them both into pure energy. However, not all unexplainable phenomena hide far away in space or parallel universes. Some of them loom in front of our eyes every single day. If compared to similar or almost identical stars, our sun is extraordinarily calm. Its luminosity changes by no more than 0.1%, which lets us live and not be burned to a crisp in hellfire during solar storms. What's more, our moon is quite abnormal too. Its radius is around 1/4 that of the Earth. This is why our satellite is unique in outer space, and there are still no keys to its secrets. But even if we never find them, we should still thank all the anomalies for making life on Earth possible, and sometimes completely incomprehensible.